see this? Again, don't copy it down until I tell you whether it's a good graph or not. So let me turn on my Ranger. I'm going to change something up from what you guys did before. 15 seconds is way too long. So where it says real time, I'm going to hit no, and I'm going to change this to 3 seconds. And then I'm going to put smoothing on. Oops, wrong button, went too fast. Okay, so what this will do is it'll record for only 3 seconds, but it won't let you see the graph when it's being made. It's going to say transferring. And the reason is this is actually able to display all 3 graphs with only 1 motion. So that's kind of nice about this. So you guys ready? Again, don't copy this till I tell you whether it's good or not. I don't think it's going to be good. I think I pushed it too soon. But let's check. And I'm going to do it again. That's not bad. But, and that might get too close, but let me look. Okay, I'm going to cheat a minute and look at the other graph and make sure that it doesn't do what I don't want. Okay, we're good. All right. So when you copy this down, we need to agree with some spots. So let's go to this point right here where it starts the parabola. And that should be right about 0.5 seconds. So probably right about your vertical line is where your parabola should start. This is the top graph. And then what might be another interesting place to find out where that occurs? Maybe the lowest point, right? So let's trace it and figure out where that occurs. So I'm looking for the time. 1.7 seconds, so try to, again, show the lowest point of your parabola around 1.7 seconds. And then it ends at around 3 seconds, so just end yours. Ours took a little longer than I thought. So if you have to, just make one more dashed line and have it end around 3 seconds. Yeah. So again, you only have up to 2.5. If you make another dashed line, you should be able to get that. Okay, so I'm going to go to this point right here. And I want to talk about that point. Just a minute. Again, you're just rough sketching it. Okay, so it ends at around 3 seconds. That lowest point is around 1.77 seconds. And then it started its motion at, was it around half a second? Parabola part? Okay. Yeah, kind of, except it doesn't go all the way down. But, yeah. Again, I'm not going to collect this. This is just kind of for you. All right, which one? Yes. Yep, it's in the first one. Yeah. Okay, so let's comment on a couple things. This is only in the first quadrant, but that makes sense because the other quadrant would be over here. And this detector can't pick up over here. So this graph is in the first quadrant. You see where the little cursor is? What's so special about that point? Where is it there? The lowest point on the graph, but where would it be on my ramp? The highest point on my ramp, right? Because it's closest to the detector at this point. So where it's blinking right now is where it's at its maximum point. Now, this does not give information about velocity. This is a displacement graph. But what do I have in my hand? Slopometer. I care about the parabola part, so I'm not going to worry about that little flat part. Okay, so my slopometer, positive or negative for slopes? That starts with negative. What happens to the steepness of it as it gets there? Gets flatter, right? Okay, what is the steepness of it right there? 0, right? It's flat. Okay, and then what starts to happen to it as it rides up the rest of the graph? It gets steeper. And positive or negative? Positive. Okay, now, what I'm going to do is show you what the velocity graph looks like. I do not have to rerun it. So take a look at the velocity graph. Do not trace this in yet until I tell you where the certain spots are. So I'm going to go to the lowest point here. And on your middle graph, okay, so the middle graph, you should have a first and fourth quadrant. This lowest point is right around 0.75-ish. And then it looks like it goes up and crosses the x-axis. Let me get where that is. Huh, that's interesting. It crosses the x-axis at 1.77 seconds. That's interesting. Right? Where was that on our top graph? The lowest point, okay? So it looks like it crosses the x-axis at the place that it was at its lowest point. And then up here, I don't really care so much about the rest, but this ends right at about 3 seconds-ish. But what I really care about is this point where it crosses, that 1.77 seconds, because that's at the top of the path. So the cart rolled up the ramp, that's at the top. Okay. Yep. So dip down. Yep, so dip down, then go up and cross, and then at some point it levels off. Yep. Okay, so what is the velocity right there that the cursor's blinking at? 0. Is that what you predicted? That it would stop at the top of the ramp? Yeah, okay, good. So I bet a lot of you got that prediction right. According to this, it was at its closest to the detector at 1.77 seconds, and according to this, it has 0 velocity at 1.77 seconds. Okay, so again, what I really care about on this graph is this part right here. The other parts are when I was pushing it or when it hit the book on the way down. What shape graph does that look like? A linear graph, right? Now this is a velocity time graph, so I've got my slopometer, maybe. I got my slopometer. As it rides up the line, what do you notice about the steepness of your slopometer? Stays the same. Remind me what the slopometer gives me on a velocity time graph. Acceleration. Okay, so everybody ready to look at the next graph? You ready? You've never seen this kind before. This is an acceleration time graph. And anyone want to take a guess what point I'm going to go look for? 1.77 seconds, right? But for those of you tracing it in, let's go down here to this low. Oops, too far. Those of you copying this down on your bottom graph, this occurs at about 0.5. So the low point there is about 0.5. I really don't care about that point. I really only care about it when it starts right about right here around 0.8 is where it starts with this flat part. And then I'm going to go find that 1.77 seconds because that's where it was at the top. And I think you guys are going to be surprised here. Some of you I saw had the right prediction, but some of you didn't. And that's okay. Right there. 1.77 seconds is right there. Walking around, it looked like a lot of you put 0. And that's okay. This is a huge misconception for students. According to this, does it have no acceleration at that point? It has acceleration. Specifically, its acceleration at that point is 0.54 meters per second squared. So what you may want to do, and again, I don't really care about the rest of it. That's the point I care about. What you may want to do is point to that part of your graph and say at the top. So where this cursor is blinking, oops, sorry. Where that cursor is blinking, point to that and say at the top. And then you might want to say not 0. It is not 0 there. And then go back to the velocity and the displacement graphs and do the same thing. Where it crosses the time axis, point to that. It is 0 there. And then on the parabola, point to the low point and say at top. So what we care about is this top number. So, yep. Or 0. So in your case, assume the positive direction is down the ramp. So you predicted correctly. A lot of people predicted 0. Yeah. Okay. Again, if your prediction was wrong, it's no big deal. Second hour, I don't think I saw anyone had the right prediction. So those of you who predicted positive for acceleration, you were correct. Those of you who predicted 0, it's okay because that's a common misconception. So shall we talk about why it's not 0? For fun?
Why is there negative?
Why is there negative? That was me pushing. It picked up my push, and I was pushing towards the ramp. Okay. What I care about, the important part of this graph is between my fingers. Do you guys see how that's a horizontal line? Okay. So we are going to put what I'm going to say in our notes in like tomorrow. We're not going to get to this part of it today. But some of you are just scratching your head going, this makes no sense, Mrs. Stone. How can it be at rest at the top and have an acceleration? It just makes no sense to me. So what I want to do is imagine a world where it did have no acceleration at the top. And I think you're going to see that shouldn't make any sense to you. Okay, so when I throw a ball straight up at the top, does it stop? Doesn't it stop? Yeah, it stops, right? Its velocity is 0. I agree with that. If I throw it straight up, which is hard to do, straight up, it stops at the top. A lot of you predicted it would have 0 acceleration, and I want you to truly think about what that would look like. Acceleration is defined as change in what? Velocity over time. So if this at its top truly had no acceleration, what would happen to the ball when it stopped? It'd stay there for how long? Forever. Okay? So for those of you who predicted 0, 0, your world would be it'd be very weird. So like I jump up like this, and you'd have to pull me down. Okay? If it truly was 0, 0 at the top. What is causing the acceleration, by the way? Gravity, right? Now, this, would you agree 0.541 is not gravity? That's not gravity, is it? But look at my ramp. What do you think would happen to that y value as my ramp got steeper?
That y value will go up.
It's going to go up. What would that y value look like if the board was completely vertical?
It would be
9.8, right? Okay, so I just wanted you guys to see this, because no matter how many times I tell you that it's not 0 at the top, until you actually see it, it's hard for students to trust me on this. Is that blinking cursor showing 0 acceleration? No. Okay, so we're going to do a little bit of notes, not a lot, just a tiny bit. So, question?
So, with the ramp, hypothetically,
Yeah.
the ramp is at 45 degrees.
Right.
It would be half of
It would actually be square root of 2 over 2. Oh! Those of you who I said that to, what is square root of 2 over 2? 40. What about? It's the unit circle, it's the sine or cosine, right? Yeah. Yeah. Oh, you thought you'd never use the unit circle, right? Okay. I'm going to put this away. We're not doing anything on the back. Okay, so just cross off the back. These become your notes, and now we're going to take some actual notes about this. Okay? Again, your brain might be blowing off your head going, oh my gosh, it's not 0 at the top. Yes, the unit circle does have some use in physics, but not a ton. So grab your note, pack it out. It's a change in displacement over time. Right? So it can. Negative just stands for direction. So it can be negative. It's just a direction, though, Jacob. So speed has no direction. Speed and velocity are very similar. All right, again, you guys grab your notes out. We're just going to do a teeny tiny bit. Page 12 is where we're starting. Okay, so page 12. So remember, this is not on your quiz tomorrow. What we just did is a demo. What we're doing right now is not on your quiz. Okay? So this picture is supposed to be a particle model of a ball being thrown straight up and coming straight back down. Now, it does have some arc to it, but I had to do that so that they don't lie right on top of each other. So envision this as straight up, straight down, except the person is throwing it from a cliff. So instead of catching it at the height it launched, it falls further down. So what we're going to do is we're going to, for these different times, and you can see those times listed on the parabola here, we're going to list what the velocity and acceleration of this particular item is at those times. So just checking something a minute here. Okay, we're good. Last night when you did your homework, we made direction down be positive. Do you agree that we've got up and down in this? So we really have to be a little bit more careful about direction. So I'm going to make up be positive and down be negative in this analysis. I didn't have to do that last night. And the reason I did